Hey, this is Chris Plush from CG Masters. In this lecture, we're going to take our carbon fiber shader from part 1 and add a couple extra nodes to give it a more realistic anisotropic effect. The shader we've already created fakes the carbon fiber effect by simply assigning different colors to the bands. This is an Eevee compatible setup though, so it's good for Eevee renders. But in Cycles, we can use a different effect for a more realistic result, because the illusion of different colored bands is actually caused by the bands stretching reflections in different directions. And this can be achieved with the principled node's anisotropic option, which simulates this stretch reflection effect. So here I'm working with a plane again to make things easier, and I've set my render engine to Cycles over in the render properties. So let me press the Z key in the 3D view and get a rendered preview going. So this is our shader so far. And in this scene I'm only using a point light for lighting now so that we can focus on the reflections. And for right now, let's go over to the principled node and we'll turn clear coat down to 0. And now because we'll no longer be faking the different colored bands, let me go over to the color options here and I'll make them both a lighter gray. So I'll click on RGMB, type in 0.3 for that, and to copy that down to the bottom one, I'll just click on it and drag it down there. Now we actually don't have to do much to get this effect working. So first, let's go over to the principled node and we'll turn the anisotropic effect up to 1. Now you can see this begins stretching the reflection, but not in the way we want. By default, it's stretching the reflection radially on the z-axis, starting from the center point and stretching it outward, kind of like the bottom of a steel pot. So we need to change the stretching, and we can do that with the tangent node. So let me zoom out, and I'll select those two nodes and move them over a little bit. We're going to add a node right in there. So let me press Shift and A, and from the input menu, I'll add in a tangent node. And now let me connect the tangent output to the tangent input of the principled node, and now we can use these options here to change the direction of the stretching of that effect. But we actually don't want to use the radial option at all because that's going to be using world coordinates and we're using UV coordinates. So let me switch that to UV map. Alright, cool. So now it's using the UV coordinates and you can see that the stretching is happening along the surface now instead of that radial stretching that we were seeing before. And if I go over here and I change the anisotropic rotation value here, you can really see how the reflections are being stretched in one direction. Now the trick here is to get each direction of banding to stretch the reflections in different directions, and that's going to give us that contrast between the bands. So we want one direction of banding stretching the reflections in this horizontal direction that we're looking at right now. Then we want the other direction of banding to stretch the reflections perpendicular to that, or 90 degrees, which would be a rotation value of 0.25. This slider only goes from 0 to 1, 1 being 360 degrees, so since 90 is 1/4 of 360, that's a value here of 0.25. Alright, and let me set this back to 0 for a minute. So what we can do now is use the zigzag mask we created over, where is it? Right here. We can use this zigzag mask to control the anisotropic rotation for each direction of banding. So let me plug the principled node back in, and let's plug the color output of the zigzag pattern there in as the anisotropic rotation value. So you can see it didn't change anything quite yet, and that's because the colors of the zigzag mask are black and white, which are values of 0 and 1. And in terms of rotation, 0 degrees is the same as 360 degrees, so we need to convert one of those values to 0.25 instead to get that 90-degree rotation. So let's use a map range node to convert the values. So let me press Shift and A, and from the converter menu, add in a map range node, and drop it over that line so that it connects. So with this node, we can convert our 0 to 1 values to a different range. Right now it's converting 0 to 1 to 0 to 1, so we're not seeing a difference yet. But let's convert our 0 value here to a value of 0.25. And there you go. So now you can see we have stretching happening in both directions, and that's all depending on the direction of the banding thanks to that zigzag mask. And this is all creating a very sweet contrast between the two directions of banding, just like in real life. You can see how some of these bands look like they're black while others are really reflective. So everything's working perfectly. Right now the anisotropic effect might be a little extreme though, so maybe I'll turn the anisotropic value here down to 0.9 to kind of spread it out a little bit. And the roughness value can be adjusted here too for a more metallic look, but roughness is essential for anisotropy to work. For example, if I turn that down to 0, we no longer get that effect, so make sure you don't go down too far. I'm going to set this to maybe 0.3, just for a more metallic look. And alright, so let me check this out on a monkey head. So let me hide the plane and the point light, and bring back my Suzanne head there. Where's it at? There it is. And I had already set up an HDRI in the world just for decent realistic lighting, but I have the strength down to 0, so let me turn that up to 1. Now let me go ahead and get a rendered preview of this, and there we go. This is looking so much better, but something's still a little off. I feel like both directions of fibers are still a little bit too bright, and I think that's because initially I turned the colors to a gray value, thinking that this was more of a metal, but carbon's not metal and it's black. So let me go ahead and turn both of these colors down to black. And like I said, carbon's not metallic. And right now we have the metallic slider up to 1 to give it a little extra shine for when we were faking the effect. But let's turn this down to 0 now. And there we go. That is so much better now. So now we've got a pretty true to life carbon fiber. And I am very happy with this. And that's it. Our carbon fiber shader is now complete. And you can play around with the other settings if you want. You can add some clear coat back in if you want to. And you can even play around with these color options over here to further customize it by giving it kind of a multicolored band look like that. But that's going to do it for our shader. And that'll do it for this lecture. So I'll see you in the next one.